All right, team, in this video, we're gonna get some guidance on how to write a procedure. Let's just skip down to here. This is your procedure: action, change, measure, keep. If you can remember that, you're gonna be well off. So let's just take an example here. Let's say that you're performing an experiment to test the scientific question: how does the density of wood affect the height at which it floats in a cup of water? Simple experiment. You have the height, and you're gonna be changing the density. Density is like how thick, how close together all the matter is. So we measure it in like grams per centimeters cubed. Those are the units. So the first thing you wanna do is you want to identify the variables. So look at the scientific question. Try to identify the cause and the effect. The cause is the density of the wood block, and then the dependent variable, that's the height, the float height. So you could be a little bit more specific and say, density of the block and then the float height. And the constants, these are all the things that you didn't choose as your independent variable. Like, you're not going to change the type of liquid in the cup. You're not going to change the volume of the block, how big the blocks are, the wood blocks are, volume of block. You're changing the density, how close, what, like, it's basically, you're changing the type of wood. You need wood that has more density to it. Think of like ironwood and versus like a birch tree. Okay, so now on to the procedure. The procedure should be brief and can usually be accomplished in just 4 or 5 sentences, okay? Action, change, measure, keep. This is how I like to teach it. So the first step just describes the main action of the experiment. So tell the scientists what they're gonna do to provide some constants. Just very general. Like, what are they gonna do? They're gonna place a block into a cup of water. So just say that. Just go right out and say, hey, place a block of wood into a cup of water. That's fine with me. Never say, first we are going to gather the materials. No, never say gather materials. I don't care about any of that. I want you to just give a quick command. Place the block of wood into a cup of water. Do this. This is not, we did this or we are going to do this. No, these are all commands that you're giving to future scientists. Cool. The next thing is you're going to, this is the nitpicky stuff. This one is all about explaining how you will change and measure the independent variable. So now we're all about the independent variable. So start with the word change. You're telling them, what are they going to change each test? So they're going to change the density of the wood block each test. Block each test. Now, this is where I want you to be specific. I want you to tell the scientists exactly what values, what numbers to test. You're going to tell them, hey, test a 50 gram per centimeter cube block. Test a 100 gram per centimeter cube block. Test a 150 gram per centimeter cubed wood block. And so on. You want to have at least 5 values, 5 numbers of the independent variable. Grams per centimeter cubed, that's 4, and then 250 grams per centimeter cubed. I'm going up by even increments. I want to make sure that I do some doubling, some tripling. I really am intentional about the values that I'm picking. I'm trying to be intentional about those values. Whoop. Okay, so good. You can also say how you're gonna get these different densities, like measure the volume and then use a scale to measure the mass. You could go specific if you really wanna go good to great. Next thing, this third step describes how you will measure the dependent variable. Don't forget to mention any scientific instruments or measuring tools. So what's the dependent variable? It's the height at which it floats. So measure the float height. Float height using a meter stick. So I mentioned the scientific instrument or the tool. Good, that's important. You can go good to great again on this. You can say measure the float height at the center of the wood block. because there's probably a difference between the height there versus the height there versus the bottom of the block. So anyways, you can go good to great and be a little bit more specific. And then the last thing is just tell me about the constants. Keep the type of liquid in the cup constant. Type of liquid. Keep the type of liquid constant each test. For each test. Each test. Good. Simple as that. And then list the other ones as well. Like keep the volume of the block constant. Keep the, you can have a few constants in that fourth step. That's fine. The last step, yeah, that's just what variables are you going to need to keep constant? What are you not changing? What did you not pick as your independent variable? And then tell me about it. The last part is just add a label diagram. At the top there was that picture, but I want you to practice your drawing, your modeling, and make sure that you label everything. Wood, block, I don't know, like density of whatever. So make sure that you're labeling everything. Water. This is an incomplete and not neat diagram. I expect you to spend a little bit more time on yours that are actually graded. So anyways, that's it. But just how to write a procedure right here. Boom. Action, change, measure, keep. And you're going to